Bismillahirrahmanirrahim. How are you, dear student? Hope you are fine, good, and great. Uh, this is Ziaul Haq, your physics teacher. So, today we are going to discuss or solve some example or problem of the Newton law of motion. So, I mention here part 1. Inshallah, in this chapter, we will solve. I try to solve more question, but I divide the question into three parts, like part 1, part 2, part 3. So in the first part, I'm going to solve just three examples. In the next video, inshallah, again three example. In the third video, also inshallah, three example. Okay, let's start the first one. Let's see what is this, what they want. A force of 20 Newton accelerate a block from rest to 20 meter per second over a distance of 80 meter. What is the mass of the block? Like they said, for example, here is the one block of mass. It covered the distance 80 meter. At the beginning, their initial velocity is equal to 0 meter, but after, when the velocity reached to 20 meter per second, mean Vf is equal to 20. So they said in the force applied on this object is 20 Newton. So this is the summary or diagrammatical form of this subject. So they said what is the mass of this block? They want this mass. So let's see, here also I mentioned a force of 20 Newton block rest to accelerate from rest to 20 meter per second. Let's suppose I mentioned here the rest word. So we said in the previous video, rest mean what? Initial velocity is equal to 0. Final velocity is already given, which is equal to 20 meter per second. The force is also given, which is equal to 20 Newton. In the distance is equal to 80 meter. They said find the acceleration and mass. So let's see, to find the acceleration, I will use the third equation of motion. This equation 2a delta x is equal to vf square minus vi square. So here only the acceleration is unknown, but the rest of value is known. So 2a multiplied by the delta x is 80 meter is equal to vf square is 20 meter per second square, sorry, whole square in minus vi is equal to 0 meter per second whole square. So now multiplied the value. So 2 multiplied by 80 is 160 meter. A is also acceleration. We will find this value. And if we square, take the square of the 20, so this is equal to 400 meter square divided by second square. So now this is 0, so this will be cancelled. So now if I want to find the acceleration, so divide both side by 160. So now this will become 400 meter square into second square divided by 160 meter. So let's see, meter will be cancelled with square, and if we divide 400 by 160, so now the acceleration is equal to 2.5 meter is remain and divide by second square. So this is the acceleration. Now in the next step, how can we find the mass? So a very famous formula, F is equal to ma. So F is how much we have, 20 Newton. This is given in the question. Mass is unknown. And acceleration already we find, so which is equal to 2.5 meter per second square. So now if I want to find the mass, so now this will be equal to 20 divided by 20 Newton divided by 2.5 meter per second square. So cancel this one. So this is equal to 8 kg. So this is the mass of the this is the unknown mass, mean the mass will be equal to 8 kg. So this is the example number 1. And next, let's see, a 900 kilogram car is to accelerate from rest to 12 meter per second in 8 seconds along a straight road. How large a force is required? In this case, this is also a same example like the previous, but here we will find the force. The mass is given, and also rest initial velocity is given, the final velocity is given, time is given. So let's see, I already the given value I already wrote. Mass is 900 kilogram, initial velocity is 0 meter per second, vf is 12 meter per second, time is 8 second, acceleration is unknown, and force is unknown. So to find the acceleration, we will use the first equation of motion, which is equal to vi plus at. Now this is 12 meter per second and vi is 0 meter per second, and acceleration is unknown in the time is 8 second. So if we want to find the acceleration, so this is equal to 12 meter per second is equal to a into 8 second. So now divide both side by 8 second. 8 second on left side and right side, so this will be cancelled, so a will be equal to 1.5 meter per second square. So this is the acceleration. Now the second part is remain, so we will find now the force. So force, we know that from the Newton's second law of motion, which is equal to ma. Mass is given, mass is 900, acceleration we already found here, which is equal to 1.5. so if we put the value here, mass is 900 kilogram multiplied by acceleration is 1.5 meter per second square, so this is equal to 1350 newtons. So this is the required force. On the next example, let's see, there are two blocks. They said find the tension force, T denote the tension force, the mass is given, and also they said find the acceleration. If you read this subject, so this is the value which is given, like mass 1 is 4 kilogram, mass 2 is 6 kilogram, force is 20 newton applied on this system. Acceleration is unknown, how much acceleration this produce this force, and also T is equal to tension, force is unknown. Okay, let's see here. To find the acceleration, we will use the second Newton's second law, like F is equal to ma. Now in this case we have two mass, so I can also write like m1 plus m2, because we have two mass in time what acceleration. So the external force which is applied on the system is 20 newton, m1 is 4 kilogram plus m2 is 6 kilogram, and time acceleration. So now this is equal to 10 kg time acceleration, and this side is 20 newton. So acceleration will be 20 newton divided by 10 kg, which is equal to 2 meter per second square. So this is the acceleration. And next, if we want to find the acceleration, tangent force, one thing remember for the tangent force, that if we find the tangent force from this side or from this side, this must be equal. Like for example, if I want to find the tangent force from this mass of block or this mass of lava, if I find this one, so this tangent force, this side tangent force must be equal to this side. Let's see how. T is equal to ma. So T, like tangent is a types of force, I can also use here instead of F is equal to T. So now the mass we will find the mass on we will find the tangent force on mass 1. So I put the m1 here. So m1 is 4 kg, and multiplied by acceleration we already found, which is equal to 2 meter per second square. So now the tangent force 4 multiplied by 2 is equal to 8 Newton. If I want to find the tangent force this side, so let's see how these are equal. So this is the positive side force, and this the tangent is negative side force. So I can also write F minus T is equal to, in the mass here which is given, is m2a. So let's see here, this is 20 Newton minus T. I want to find this one. m2 is 6 kg and acceleration is 2 meter per second square. Acceleration will be same for the whole system. So now let's see here. So this is equal to 12 and minus T, and this is 20. If we turn this value 20 to there, so this will minus T, remain minus T, and here 12 minus 20. So this is equal to minus 8 Newton, and here is minus T. Minus will be cancelled with minus. So this is also minus 8 Newton, and this side also 8 Newton, and this side also 8 Newton. Okay, thank you so much for this one. Now we are going to solve more question in part 2. If you have any question in this part, so you can ask in your comment. Thank you so much.